Hello everyone. The topic of this short presentation is superposition, merging, and splitting with respect to the Bernoulli process. So first, I will give a quick review of Bernoulli process. I think all of you know the Bernoulli distribution. And Bernoulli process is a sequence of independent trails of Bernoulli process, just like it's a sequence of 0 and 1. And Bernoulli process is orderly, means you can get two outcome at the same time. And it's memoryless, means outcome of each time slot is independent. So let's first talk about the superposition. Superposition means that we combine two or more independent Bernoulli processes into a single process. At each time slot, the outcome is the sum of outcomes from multiple Bernoulli processes. And each time slot is a binomial distribution with parameter n and p. We will have an example later. Now let's give an example of superposition. Assume that this is a midterm exam of queuing theory, and 1 means correct, 0 means wrong. So here we have 10 questions in this midterm, and here are 5 students. So these 5 students represent 5 Bernoulli processes. And superposition is that we combine these 5 Bernoulli processes. So let's see first column. First column is 3 students correct this question. So the value is 3. And question 2, only 1 student correct. So the value is 1. And here, each column is binomial distribution. So n equals to 5. And assume it's a multiple choice question. The probability of correct is 0.25. And now we talk about merging. In merging, we are only interested to know if there was at least one arrival within a time slot. So in superposition, we care about how many times it happens. But in merging, we only care if it happens or not. For example, here are two Bernoulli processes. And if we merge these two processes, we will get this. Then how we get this probability is that in merging we must have at least one success. So either X success or Y success. So we add this probability and this probability and this probability. So we can get the probability is P plus Q minus P times Q. And let's give an example of merging. Is still the example of midterm exam of queuing theory. And let's see question 1. 3 students correct, but we only care someone correct or not. So in merging, the value is 1. And the last question, no one correct, so the value is 0. Now let's see superposition and merging. In question 1, 3 students correct, so the superposition value is 3. So superposition is just like counting. And in merging, the value is 1 because merging only cares whether someone correct or not. So merging only have the value either 0 or 1. I hope this help you realize the difference between superposition and merging. And last, we will talk about splitting. So splitting refers to break down a single Bernoulli process into two or more separate processes. And each outcome of the original process is allocated to one of the split processes based on some rule. For example, you can give the first outcome to process 1 and the second outcome to process 2, third outcome to process 1, fourth outcome to process 2. And now suppose we split this binary process with the rule y. So we can get two Bernoulli processes. And now let's give an example of splitting. It's still an example of the midterm exam of queuing theory. And now we define that the odd number question get 8 points and even number questions get 12 points. So in these 10 questions, the total point is still 100. And we divide this Bernoulli process into two Bernoulli processes. We can see here in the odd number question, we give the outcome to this Bernoulli process, and in even, we give the outcome to this Bernoulli process. So we can calculate the student's score is the 3 times 8 plus 2 times 12. So in this short presentation, we have talked about superposition, merging, and splitting with respect to the Bernoulli process. Thank you, everyone.